Welcome to Unit 2, Modeling with Functions. In this video, we're going to talk about how to find models on your calculator with data. So in the previous video, we learned about what an actual model is. But in those problems, I kind of gave you the model. Now we're going to really learn about how your calculator will find that model for you. But first, we have to make sure that when you're using your TI-84 calculator, you have to have Stat Diagnostics turned on and Stat Wizards turned on. So if you go on your calculator, hit Mode. You gotta scroll the way down, which actually if you scroll up, it's faster to get to. Make sure that Stat Wizards is turned on and Stat Diagnostics is turned on. If those are turned off, your screen might end up looking different than mine. So make sure that those two things are turned on or things can get a little bit funky. All right, so now that we got that out of the way, here are the overall basic steps to find a model, but I'm going to go into a lot more detail on how to actually use your calculator for this. So first off, you can't find a model until you enter the data into your calculator. To enter data into our calculator, we hit Stat and then Edit. X values go in list 1, Y values go in list 2. So again, on your calculator, that's the Stat button, kind of right in the middle towards the top. And then we have 3 commands, Edit, Calc, and Test. Under Edit, the first command is Edit, and this is where you actually enter data into your calculator. So a couple things here. Let's just say that you do have some values typed in here and you don't want them there. To clear out a list, highlight the L1 at the top or L2 or L3, whatever. And to clear out the entire list, hit Clear Down. Don't ever hit the Delete button because you will literally delete the entire list. So if you do have a list 1 or L2 or L3, if you don't have those there at all, if they're like gone, then you need to enter them back in. That's a whole different story you could talk to me about individually, but make sure you have your list there. Now, everything I do in this video is going to be using list 1 and list 2. You don't have to. You could use list 3 and list 4, but you just have to make some adjustments, and I'll kind of explain that as I go throughout the video. All right, then we actually have to make a scatter plot of our data. In some problems, I might give you the scatter plot, but if you're going to have to find the model, you're going to need to make it on your calculator. So if you don't know how to make a scatter plot in your calculator, what you do is once your data is typed in, I don't have any data typed in right now, I'm just kind of go over the process, but the first thing you have to do is hit Y equals. Make sure you don't have any equations typed in there, because if you do have an equation typed in there, maybe from a different class, then it's going to try to do a scatter plot and an equation at the same time, which can sometimes confuse the calculator. But then what we want to do is hit second Y equals. This is where our stat plot command is. And you do have 3 different stat plots. We'll only use one at a time. So just go to stat plot 1. You could turn it on by just highlighting the word on and hit enter. And the type is a scatter plot. So it should be the very first one there. You can kind of see it looks like a bunch of dots. Make sure that that is entered as well. And then you need to make sure that you're telling the calculator where your X data is and where your Y data is. So that's why I told you to use list 1 for X's and list 2 for Y's. But in case, maybe for some crazy reason you use L3 and L4, then this is where you would need to make an adjustment to tell the calculator, hey, my X's are in L3, my Y's are in L4. Now, where do you get the L1, L2, L3s? Because it's not the alphabet letter L, it stands for list. So these are actually above the numbers. So if you look on your calculator, number 1, 2, 3, 4, 5, and 6, you'll see above them in blue an L1, L2, L3. So to get that little L1 right there, you don't type in L and then 1, you type in the command L1, which is second number 1. And then for list 2, it's second number 2. That's where those actual L's are. Those stand for lists. So notice that's not an alphabet letter L and then a 1. So please don't accidentally try to do that. Calculator's going to get very confused. Now, in terms of finding the model that best fits your data, well, obviously you need to look at the scatter plot. And from looking at the scatter plot, you're going to decide which model to use. Now, once your data is all in there, you could take a look at your data by hitting Zoom 9. Zoom 9 is the Zoom stat. So anytime something gets entered into the stat command, which is where we enter our data in by hitting stat edit, you need to view that again by zoom and then number 9. Oops, sorry, I got a bunch of different things here. Anyway, Zoom 9 is the Zoom stat. So that'll actually zoom in on anything that you enter into the stat command. So that's how you actually see your scatter plot. So again, you got to make sure your stat plot is turned on. Make sure you're using the correct data, L1 and L2. And then Zoom 9 actually will see your data. Now, to actually get the different models, you're going to hit Stat, slide over to Calc in the middle, stands for Calculate. And this is where we have all the different models. So number 4 is our linear model, AX plus B. Number 4 is the quadratic model. 6 is cubic. 7 is quartic. 8 is another version of a linear model, but notice they put the X with the B. So most kids don't use that, but most kids are going to go with number 4. It actually doesn't matter. Like, for example, the A value in AX plus B is the slope, but in this number 8, it's the B value is the slope. So you don't have to get confused if you don't want to. Just don't use number 8, use number 4 for the linear regression. Then we have our natural log, our logarithmic regression. We have our exponential regression. Power regression. And if you're like, what's regression? Regression is just another word for model. I mean, there's a little bit more to it, but that's for a different class. But just think of the model, the power model, the exponential model, the logarithmic model. And then we also have the logistic model there, okay? You can actually do sign models, but we're not going to deal with any sign models right now. So this is where you'd actually grab all those, okay? So after you do that, then it's going to, and again, I got to show you an example for it to actually work, but you're actually going to see the equation that you need to use and the coefficients that we're going to learn. So remember, these are all the different models: linear, quadratic, cubic, quartic, exponential, power, and logarithmic, and then logistic. So the one place where a lot of kids get confused, I just want to go over this one more time, is when the exponent is the variable, right? The exponent is a number. We call that a power function. So the base is x, the exponent is going to be a number, right? So it says it's b, but it could be any number. Remember, even fractions like 3/4 or 1.7, right? When the exponent is a number, you're not exponential. When the exponent is a number, you are a power function. But when the base is a number and the exponent contains the x, that's exponential. So please make sure you know the difference between exponential and power. And then again, the logarithmic models here and the logistic model. But notice that every one of these has variables: A, B, C, D, quartic even has an E. Keep note that with the logistic model, this is not a variable E, that's the irrational number E. So I know it's a little bit confusing, but right here in the quartic model, this E is a coefficient. It's actually a variable, it's not the irrational number E, which gets a little confusing, I understand. But again, when you use those commands on the calculator, which I'm about to show you, you will be given all of these different coefficients. That way you could write out the equation. All right, so let's just dive into our first example. This is the example we saw in the previous video. And I want to show you how I got 1.055, 1.586 raised to the x. Okay, so once again, this represents years and the number of new coffee shops by a particular store in each of those years. So the first thing I got to do is enter the data into my calculator. So stat, edit. Now remember, we're letting x equals 0 represent 1980, so I'm not going to type in 1986. I'm going to type in 6 because it's 6 years from 1980. 7, 8, 9, 10, 11, 12, 13, and 14. Please really take your time and double check that you type all those in right, because if you type in a little bitty number wrong, you're going to get the whole problem wrong. So 1986, there were 14, 27, 48, 80, 110, 153, 261, 403, and 681. All right, and it really is worth it to go back through all those and double check that you didn't type anything in. Make sure they all line up. So 11, which is 11 years after 1980, 1991 should be the 153, and so forth, because I can't tell you how many kids get a poor grade because they typed their data in wrong and then they come crying to me. So please don't do that. Double check your work. All right, so once you got the data in there, again, we want to make a scatter plot of it. So that's the scatter plot I have shown here. So I'm going to hit second y equals. Let's go to my stat plots. Once you do this one time, it should be on until you turn it off. So I've already done this, so it's already on. The scatter plot is highlighted, and the x's are list 1, the y's are list 2. You could choose the different mark, whether you want to use little plus signs, little dots, little squares. It really doesn't matter, whatever you want to use. And once you're all done with that, again, zoom 9 is the zoom stats. That's how I got that beautiful picture, and practice that you can get that same picture. So now you got to pick, right? Do you think that looks like a line? No, it clearly doesn't look like a line. It looks exponential, right? I see this exponential growth. Now, maybe you thought that this was quartic or quadratic. And again, we're going to explain how you should know the difference, but hopefully everybody sees that that's clearly exponential, that classic exponential curve. So once again, I'm going to go stat, because now I want to actually get it. So once I decide I need the exponential curve, I'm going to hit stat, go over to calculate, And I'm going to scroll all the way down to the exponential, which is the EXP regression. So that's an exponential regression or an exponential model. And it's going to come up with this little menu here. It's going to just double check that you have the right data. So X's, the years, are in list 1. Y's, the number of stores, are in list 2. The frequency list, always leave that blank. Don't type anything there. Now, this is another cool thing you could do. You'll notice that another step is putting your model onto your scatter plot. And you could actually have the calculator do this for you. So we're going to ask the calculator to store the regression equation that it's about to come up with in Y1. So to get Y1, you're going to hit vars, which is right next to clear, stands for variables. Slide over to Y variables, Y vars, function, and then select Y1. So what this is going to do, this is actually going to take the equation that it's about to come up with and store it into Y1. That way, when we hit graph, we'll see the equation on top of the scatter plot. So pretty cool. So go ahead and hit calculate. And sometimes it takes a little bit of time. That one actually took pretty quickly, but we'll notice a couple things here. So first off, notice that the very top line, it gives the equation. It gives the exponential model A times B raised to the X. Then underneath that is it tells you what A and B are. Now, read problems. Most of the time, I'm going to ask you to round to 3 or 4 decimals. So you notice I rounded to 3 decimals here. But sometimes I might ask you to round to 2, 3, or 4. So make sure you read the problem to know how many decimals to round to. So the A value is out in front is the 1.055. And the B value is the 1.586. Again, for 3 decimals, the 4th decimal tells you what to do. Stay or go up. Now, briefly, if I really wanted to get super statistical on you, I could talk to you about what R squared measures. But R squared is basically essentially just telling you how good of a fit it is. And the highest R squared value could ever be is a perfect 1. So 0.9926 is a really high R squared value. That's what tells me that my model is pretty good. It's modeling the data very well. Again, a perfect model, if it was exactly perfect, all my model fits perfectly with the points, which is never going to really happen in the real world, that would be a 1. So 0.99 for R squared is really, really good. And I'm going to show you something in one moment that would be really, really bad. But anyway, once this is here, again, make sure you write this down. You're going to write down your A value, write down your B value, actually write down the equation, 1.055 times 1.586 raised to the X. That's your model. Now remember, if you click Y equals, remember we asked the calculator to store that equation in Y equals. And it's pretty cool because when it stores it, it doesn't do any rounding. So it keeps all those decimals. It keeps a lot of them. So then there's my A, and here comes my B value, all raised to the X. So it stores it for you, just saves you the time from having to type it in. Then when you hit graph, you'll be able to see the beautiful exponential going right over top of it. And it doesn't fit every point exactly, but it is really, really close, right? And again, that R squared value told me that it was going to fit the data well. Now let's just play a pretend game real quick. Let's just say you looked at this and your first thought was, oh, maybe this is quadratic. So you're going to go to calculate, and you're going to go down to quadratic because you thought that that kind of looked like half of a problem, which, I can't argue with you, and maybe you would think that. So you go, same thing, X lists, Y lists, and you could ask the calculator to store it as, again, Y1, so vars, Y vars, function, Y1, store it, calculate. Now check this out. We get the formula written. The top line is always going to be the formula written for that model. This model is quadratic, so ax squared plus bx plus c. And again, here is our coefficients, a, b, and c. But notice the r squared value here is not as good. It's 0.9689. Now listen, that's still pretty good, right? Remember, 1 is perfect. So 0.9689 is good, but remember, the exponential model was a lot better. It was 0.99. So if this is a test or a quiz and you're trying to really find the best model, sometimes you got to try a couple of them. I'm obviously not going to try linear here. It clearly doesn't look linear. It clearly doesn't look logarithmic. So if you know the models, then you know kind of what not to try. But if you're thinking, well, I'm debating between quadratic and exponential, that is kind of how you're going to really determine which one is the best, by using the best r squared, which again, closer to 1 is better. And the other thing too is if I hit graph here, notice that the graph doesn't really fit the data as well. I mean, it doesn't fit it terribly, but if you look at the picture I have down here with the exponential model, it clearly fit the data better. I mean, it's just, it really is in line with almost every point. where the quadratic one is it's just not as good. And that's another sign that the quadratic model is not as good as the exponential one. So that's a quick run through of how I got that formula, right? Which is pretty easy. All right, let's try another one here. So this is the one where we're looking at temperature versus temperature versus the number of pop canceled on a vending machine. So once again, now I'm starting a brand new problem. So I'm gonna go stat, edit, and now I gotta clear these lists out. So remember, highlight L2, clear down. Highlight L1, clear down. Don't ever hit the delete button. You'll literally delete the whole list. And start typing in the data. All right, so I'm going to go ahead and pause the video real quick and type it in. That way you don't have to waste too much time, but you can obviously start typing in as well. And voila, all the data is typed in there. Now, remember, we've already been graphing, but let's just say this is the first problem of the day. You're going to go to y equals, make sure any previous equations are now cleared out of there. Second, y equals is your stat plot. Just make sure it's on. Make sure the scatter plot's selected in L1 and L2. And then we're ready to do our zoom 9 to look at it, and there is the scatter plot that we see. So again, if I'm looking at this, the first thing that I see is that pretty much looks like a line. It's not perfect, but it looks pretty linear. So stat, over to calc, I'm going to go to number 4, the linear regression, ax plus b. And again, make sure you got L1, L2. If you accidentally used L4, remember, that's okay. You could type your data in L4. You're just going to hit second, number 4 to pull up L4. So again, I always recommend using L1 and L2, but you could use other lists. Just got to make sure to type them in correctly. And then I'm going to store this equation vars, y vars function y1. And then go ahead and calculate it. Notice it gives me the equation, ax plus b. So I now know a is 16.416, b is negative 621.826. And again, the r squared value is, it's not great, 0.9357. That's pretty good. Remember, the best is 1. And then again, write that down, right? So there's my equation. I wrote it down. So make sure you write it down. And then when you hit graph, because you asked it to store it, you'll see it there. Now, if you do think there's a better equation, try one. Try quadratic, try power. But again, always look at that r squared value. Maybe you want to write them down as you go. Okay, the linear r squared value is 0.93. And, ooh, can I do better? And then try a couple other ones, right? It really doesn't take any writing work. The only work you have to do is type on your calculator to try different models. For example, if let's just do it real quick. Let's say I wanted to try, a cubic model. Like maybe I thought this somehow fit a cubic model. Again, L1, L2, store the calculator or store the equation on my calculator's vars, y vars function y1. And you realize, actually that r squared value is better. So let's take a look at the graph. Maybe this one fits it even better. There you go. That actually does fit it pretty good. So, lesson learned, right? Maybe that one would actually be better for this data than the linear model I thought. So again, that's the whole point of just kind of experimenting and seeing what model is truly the best model for your data. So, okay, let's do one more example here. This is our logistic model that we saw with the population in Florida. So once again, stat, edit, highlight L2, clear down, get all that old data out of there, clear down, get all that old data out of there. And I'm going to go ahead and hit pause, and then you'll see here in 1 second, they're going to pop. All right, and voila, all of them are now in there. So make sure for this problem, again, X was not the year, but it was the years since 1900. So the very first point at 1900 was a 0, and then the Y was 0.5. So again, always double check your work and make sure that they're all in there correctly. All right, so now, once again, second, y equals, turn on that plot 1, make sure everything is set, L1, L2, or wherever you have your X's and Y's. Go to y equals, again, if you're working with multiple problems in a row, make sure any equation that you did have stored there is now gone. And then again, we're gonna go zoom 9 to get a look at the graph. And again, we look at that graph and we say, okay, what's going to fit that best? And maybe you do think quadratic, maybe you do think exponential, but this one I'm telling you is logistic. And, we're going to talk about this in a moment, but a lot of kids say, how do I know which model to use? in a lot of problems, maybe I tell you. I'll just say, hey, use a logistic model for this problem. But in more difficult ones, you're going to have to figure it out on your own. You're going to have to do some trial and error, try a couple different ones and see which one's best. But in a lot of your homework problems, I will start you off by just telling you which model I want you to use. But anyway, if I want to use the logistic model here, stat, slide over to calc, you're going to scroll all the way down to the logistic model. And make sure you have the X list and Y list correct. Again, we want to store the equation as vars, Y vars, Y function. And I also want to note here, you don't have to store it anywhere, but it does help. That way you could graph it easier because you don't want to self-type this equation in, especially with logistic ones and all these decimals and stuff. You don't want to type it in yourself. But technically, you don't have to store it anywhere. All right, then go ahead and hit calculate. And takes a moment. For some reason, logistic actually does take a couple moments to do. Calculator's doing a lot of thinking right now, making sure that it's getting all the right data. Beep, boop, beep, boop, 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 boop. I'm going to just keep, there it is. Okay, so notice again, the first line, it tells you all the variables. Please keep in mind that E is not a variable here. E is the irrational number, but we have a C as our numerator. Then there's our A out in front of the E, and then our B value is next to the X. All right, so notice that the B value is negative, but when the negative is in the equation. When I give you the B value, it's going to be written as a positive, but once you plug in B, it becomes a negative right away. All right, so there's my A, B, and C. Now, you'll also notice that there is no R squared value. So the logistic model is the only model that won't give you an R squared value. So it's kind of just based on sight, like just looking at it and being, wow, that really fits the data well. All right, so make sure you write that down. Notice how I actually wrote down. I rounded to 4 decimal places this time. The more decimals, the more accurate you're going to be. But make sure you read the problem to know how many decimals to keep. But write it down. Fill in your C value, fill in your A value, fill in your B value, and actually write out the formula. All right, then we could take a look at the graph. Because we did store it under y equals, the graph should now contain the model as well on top of it. And again, it fits it really, really well. So the logistic model without an R squared is going to be only by sight. You're going to look at it and say, wow, that logistic really fits it almost perfect. So that's a really good model for that. All right, so that's really it using your calculator. It is really, really simple. Now, here is what I've mentioned slightly, a minute ago. Most kids want to know, how do I know what model to use? Well, the first thing I could do is I could just tell you what model to use. That's pretty easy. There's no debating. You use the model I tell you. The second is that you will need to look at the scatter plot and make a decision. So you got to actually look, and that's kind of what I said earlier. And I would consider that a medium type of problem. But if you really can't decide, the scatter plot looks like it could be a few different models, then you need to look at that R squared value. The model with the highest R squared value, again, closest to 1, is really going to be the best model. So keep that in mind, but that's like the most difficult problem, is where it's truly a guess, and on top of it being a guess, you're really making a tough decision between a couple different models. But again, there is a right or wrong answer based off that best R squared data. All right, now, in a homework problem that I'm going to give you over this, what could be asked of you? So this is a common thing I really want to make sure I go over here. So number one is, you'll notice that I have the capability of, my calculator is built into my computer, so I can do a little screenshot and make it really nice and pretty, but I don't believe you have that. So what you're probably going to have to do is make a rough sketch of the scatter plot. So on most homeworks, I'm going to say, hey, make a rough sketch of the scatter plot that you see on your calculator. It doesn't have to be extremely accurate, just pretty accurate, like, make a rough sketch. That's what a rough sketch means. But the most important thing I need you to do is label your axes, right? So on this problem, for example, I'm going to label the x-axis as temperature in degrees Fahrenheit, and the y-axis as the number of cans sold. So always make sure you label your axes, because the calculator doesn't even do that for you, right? You need to do that, and I'm always going to remind you of that. Then you got to find the best model, right? I want a written out equation. I want a written out function of the best model, right? So actually write the function out. Number 4 is to draw the function over top of the model. So in that rough sketch that you made, I might ask you to draw your model over top of it. Again, try to be as accurate as you can. I understand you're kind of copying what you see on your calculator screen. And then I might ask you, hey, why is your model the best? And you could say things like, it really goes through my data very well. Like that logistic model, the last one we saw, it almost went through every point perfectly. That's a good answer. Or if you do have to make a choice, maybe you say, well, I tried a quadratic model and I tried an exponential model, and the exponential one fitted better based on look and based on the R-squared value being higher. It was 0.99 versus the quadratic model only had a 0.96 R-squared. So something like that is also usable in terms of answering the questions, why is your model the best? Then I could ask you to do some math, right? I could say, all right, now that you found your equation, maybe we go back here. So, okay, predict the number of new stores in the year 1997. So you got to actually plug in 17, which would be 17 years after 1980, 1997. Plug it in for X, because X is the number of years since 1980. And then you're going to get out the predicted number of new stores that year. Or I could ask you to work backwards. I could ask you to solve for X with a given Y. So I could say, all right, when do you think there will be 1,000 new stores? So now you're going to substitute in 1,000 for the Y, which is f of X, and solve for X, which is why we spent that prerequisite unit on solving equations. And again, same thing with this one, right? I could say, all right, the year's 2020. Predict the population from Florida. So you're going to plug in, 1,020, because that's 120 years from 1900 is 2020. Plug that in for X, and that's pretty easy. Just make sure you type it in correctly, and then you're going to get a predicted population. Or I could say, all right, what year do we predict the population to reach 21 million? In that case, you're going to plug 21 in for f of X and solve for X. So one way is a little bit easier because you're just plugging in for X and typing on your calculator. The other way, you do have to use some solving techniques to solve for X with a given Y. So that's pretty much a list of everything I could ask you to do because, realistically, the calculator is doing the large majority of the work by creating the model. And one more thing I do want to show you with concerning step number 6 here, predicting a Y. Remember, once you have the formula solved or stored in Y1, if I ask you, hey, what do we predict for, let's talk about the year 2020, right? That'd be 120 value for X. So again, once it's stored there, remember I showed you guys this in class, vars, y vars, function, y1. Actually go and grab y1 and type in 120, and the calculator will do all the work for you. So this is really easy. You don't even have to really show any work. So in the year 2020, the formula predicts that the population of Florida will be 21.24 million people. But if I do ask you to solve for X with a given Y, the calculator cannot do that. You're going to have to actually get your hands dirty and do some solving. All right, guys, that's it on this video over how to calculate models based on data given to you. Be prepared for several problems where you are given data and you have to make the best choice to come up with the best model. All right, guys, that's it for this video. See you later.